Good day, everyone. This is another physics section with Samsonic. Here is a banger I've prepared for you guys. Don't forget to like, comment, and share. Alright, so this is the question. It says a copper rod whose length at 30 degrees Celsius is 10.0 meter, heated to 50 degrees Celsius. Find its new length. Take alpha for copper to be that's 0.000017 per Kelvin. So in my last video, I've told you guys that whenever you're solving any physics question, you need to bring out your parameters so you will know what you are solving for in your question, right? So now let's bring out the parameters. From the question, it says a copper rod whose length at 30 degrees Celsius, we have a copper rod, then the length at this temperature, 50 degrees Celsius is what? It is 10 meter. Definitely, we're not talking about expansivity. That is, there is what? There is a change in length of the rod or material when it is applied. Just what I'm saying. So now, since we have since we have the length to be what? The initial length of the rod to be 10.0 meter and the initial temperature of the rod at this length is what? 30 degrees Celsius. So we have the initial length, which is L1, is what? 10.0 meter, right? And the temperature at this particular length, that is theta 1, is what? 30 degrees Celsius. Mind you, we are not working with degrees Celsius here, we are working with what? We are working with Kelvin. So we convert each of our degrees Celsius from our question to what? Kelvin. So now let's do that. When you convert this 30 degrees Celsius to Kelvin, you add what? 273. That is 273 plus 30, right? 3 plus 0 is what? 3. This one is 10, 0, 1, and 3. 303. So that is a conversion from 30 degrees Celsius to Kelvin. We have what? We have 303 Kelvin. So what's the next thing? Let's continue. They said find, okay, it is heated to 50 degrees Celsius. Now, this rod at this particular length and this temperature is heated to what? 50 degrees Celsius. So when the heat is applied to the rod, there is a what? Increase in temperature of the rod, right? So now the increase in temperature, or let me say the final temperature of the rod is what? It is 50 degrees Celsius. So we say the final temperature theta 2 is equal to what? 50 degrees Celsius, isn't it? So now let's convert 50 degrees Celsius also to Kelvin. The same thing we did there. Add your what? 273 plus 50 degree. 3 plus 0 is 3. 7 plus 5 is what? 7 plus 5 is 12. 2. Then we have 1. 1 plus 2 is what? 3. So we have 323. 323 Kelvin. Then find its new length. Take alpha for copper to be equal to what? This. So at this particular temperature now, what is the length? That is L2. Now the question can comes in, find the um the the increase in length, isn't it? That is delta L, right? But here now they said find its new length. Take alpha for what? This amount, but find its new length at this temperature. Do you get that now? So now what else I'll give you? They said we should take alpha, and alpha, which is the coefficient of linear expansivity, to be 0.000017 per Kelvin. So let's solve. This is our parameters. L1, the initial length, theta 1, the initial temperature, which we converted to Kelvin, theta 2, which is the final temperature, we converted to 50 degrees Celsius, we converted to Kelvin, L2, that's what we're looking for, and coefficient of linear expansivity, which is 0.000017 per Kelvin. And this depends on the type of material you're given. This is the one for copper. This is the value for copper. So now recall from our formula for linear expansivity. What do we use to solve linear expansivity? We know that linear expansivity is the increase in length per unit length per degree rise in temperature rise. So we say this linear expansivity is equal to what? The increase in length, that is the increase in length delta L over what? That is increase in length per unit length, that is the first length, per what? Per degree rise in temperature, isn't it? So here now we know that this change in L is same thing as saying what? L2 minus L1, and this same thing as saying what? Same thing as saying theta 2 minus theta 1, right? So we can bring out that we can say alpha is equal to what? L2 minus L1 over what? L1 into bracket theta 2 minus theta 1, right? So now let's continue. We are given this, we are given the initial length, we are not given this, we are given this, we are given this, we are given this. So we can solve now. Now let's continue. We have alpha, which is the coefficient of nearest facility to be what? 0.000017, right? Which is equals to, then our L2, that's what we are looking for. L2 minus L1 is what? Which is the initial length is 10.0 meter divided by L1 is 10.0, I'm going to call meter, 10.0 into bracket. The initial, the final temperature is 323 minus 303, right? So now what can we do here again? Next thing we do here is what? We open this bracket. 323 minus 303 is what? That will be 0.000017, which is equals to L2 minus 10.0 divided by what? Divided by 10.0 into bracket. 323 minus give us what? That will give us 20, right? So what's the next thing we do? We can still simplify bracket multiplying 10.0 times 20. So we have 0.000017, which is equals to L2 minus 10.0 divided by this will give us what? 20.0. I said 20, 200 rather. 200.0, right? So now this is a fraction, then you balance this also, isn't it? So it becomes 1 into bracket L2 minus 10.0, which is equals to, then we have 0.000017, then what? 200.0, right? So now when we open this bracket, we have what? 1, we have L2, 1 times L2 is L2, 1 times minus 10 is 10.0, isn't it? Which is equal to plus and finally. So 0.000017 times 200.0 give us what? That is 0.0034, right? 4. So now we are having this answer now. So we can definitely bring or collect like time here by taking this minus 10.0, causing the equal to sign, and this minus sign will change to a plus, right? So that will become N2, which is equal to 0.0034 plus what? 10.0. So we have L2, which is now 10.0 plus 0.0034. You have what? That gives us 10.0034. What's the unit of length? Meter. So here, this is our final length of the what? Of the copper rod. Thank you.